Hello students, in the last lecture we have studied about terms related to spherical mirrors. We have studied that there are two kinds of spherical mirror, concave mirror and convex mirror. We studied various terms such as pole, center of curvature, radius of curvature, principal axis and aperture. In this lecture we are going to study about a very important term related to spherical mirrors, and that is principal focus. Now what basically principal focus is? Principal focus is a point on the principal axis to which the parallel incident ray converge. I have written concave mirror in bracket. Why I have written this? This is because concave mirror is converging in nature. So the reflected rays will actually converge at a point. वो actually एक point पे मिलेंगे after reflection. Or tends to converge. I have written convex mirror. This is because convex mirror is diverging in nature and the reflected rays never converge at a point. We assume that it might converge at a point. So it is basically a point on the principal axis to which the parallel incident rays converge or tends to converge after reflection. As you can see in this diagram, it is a concave mirror. There will be a center of curvature. The center of the mirror is known as pole, and these rays are incident on the concave mirror parallel to the principal axis. As you can clearly see in the diagram, they are parallel to the principal axis, and after reflection they tends to converge at a point. Since it is converging mirror in nature, they tends to converge at a point which lies on the principal axis, and this point F is known as the principal focus. The rays are parallel to the principal axis. After reflection, they tends to meet at a point which is on the principal axis, and this point is known as principal focus. As you can see, the reflected rays are actually meeting at point F, so the image formed at F will be real and inverted. Now, if we talk about convex mirror, so this is a shape of convex mirror. Now, where will be its center of curvature? On this side or on this side? So for this, let me tell you a small trick. And the trick is, जिस तरफ भी C बने, let us see this. इधर C ऐसे बन रहा है, तो जिस तरफ C बन रहा है, उस तरफ center of curvature होगा. In this case, this is the C, so the center of curvature will be on the other side as compared to concave mirror. So, and these rays are parallel to principal axis, then after reflection they get diverged. As you can see clearly, the reflected rays are not meeting at a point, but they are moving away from each other. This is because convex mirror is diverging in nature. But what if we produce the reflected rays? Then we can see that all the reflected rays appear to meet at a point, or they appear as if they have started from point F. So we can say that an image will be formed at F, but the nature of image will be virtual since the reflected rays are not actually meeting at a point. Experimentally, it was found out that the point F is at the midpoint of the radius of curvature. Here PC is the radius of curvature, as we have already discussed in the earlier lecture that the distance between pole and center of curvature is known as radius of curvature. So here PC will be radius of curvature, and it was found out that F is at the midpoint. So we can write PF is equal to FC is equal to R by 2, and this distance PF is known as focal length. Now what is the definition of focal length? So focal length, it is defined as the distance between the pole and principal focus of a mirror. Though PF is equal to FC, but in case of definition we'll write the distance between the pole and the principal focus of a mirror, and this distance is known as focal length. Now since we have discussed that a spherical mirror is quite different from a plane mirror, so the image formed will be different, or the image will be formed at different positions of a mirror if the position of the object is continuously changed. What if we bring the object near to the mirror and then we bring it away from the mirror? In both the cases, the image formed or the distance of image formed won't be same. Even the size will also differ. So we'll study how to find out the position of image when the object is kept at different position. For this, we need to study rules for image tracing. First, we'll study rules for image tracing on concave mirror. You must remember this, all of these rules are basically based on the laws of reflection. But we have simplified this for a better understanding. All the rules are basically based on laws of reflection. So let us study the rule. The first rule is, if a ray is parallel to principal axis, then after reflection it will pass through the principal focus. As you can see, if a ray is parallel to the principal axis, then after reflection it will get reflected back in such a way that the reflected ray will pass through the focus. Parallel, it will pass through the focus. One thing you must remember is, while drawing a ray diagram, you must always show the arrows to distinguish between the incident ray and the reflected rays. The arrow towards the mirror shows the incident ray and the arrow away from the mirror shows the reflected ray. Second rule, if a ray is passing through the principal focus, then after reflection it becomes parallel to the principal axis. As you can see in this diagram clearly, a ray is passing through the principal focus, which is the incident ray, and after reflection it got parallel to the principal axis. The third rule, if a ray is passing through the center of curvature, then after reflection it retraces its own path. Now what do you mean by retraces its own path? So as you can see, a ray is passing through the center of curvature, it got reflected back along the same path. So we can say it is retracing its own path. Now what is the reason for this? See, let's say the light strikes at point X. So can we say that Cx is equal to Cp? That is, Cx will be the radius of curvature of this mirror. And as we know that if I need to find out the angle at which it is striking, then I need to draw a tangent. And as we know that the angle between the radius and tangent is 90 degree. If the angle between radius and tangent is 90 degree, then this line will behave as normal. And as per the rule, the light is moving along the normal. It means that the angle of incidence is 0. And when the angle of incidence is 0, the angle of reflection has to be 0. Hence, it retraces its own path. The fourth rule is, if a light is incident on the pole at some angle with the principal axis, then it gets reflected back at the same angle. As you can see in the diagram, the incident ray is striking the pole at some angle. Let's say this angle is theta. Then as per the laws of reflection, it will get back reflected at the same angle theta. Now using these rules, we'll find out positions of image when the object is kept at different positions. This is known as image tracing on concave mirror, or sometimes it is also referred as ray diagrams. So let's study the ray diagram. We'll consider different cases and then we'll study each case separately. Study the first case. Case 1, when the object is kept at infinity. It means the object is kept very far away from the mirror, so we can assume that the object is at infinity. While drawing this ray diagram, we must remember 2 points. First, we won't be drawing the object. As the object is quite far away, we won't be drawing the object. Second, we'll assume that the incident ray must be parallel to each other, and most probably they must be parallel to the principal axis. So while drawing the case when the object is at infinity, we'll remember 2 points. We won't be drawing the object, and secondly, we'll assume that the incident ray must be parallel to each other, and also it must be parallel to the principal axis. Now how to draw this diagram? See, you can draw it in rough, but I prefer to draw it using certain measurements. Now what is the use of drawing it with certain measurement? It is that even if you forget something and you're drawing a ray diagram with proper measurements using the rules which have been taught, then you won't get it wrong. You would be able to easily understand them and draw it very nicely in your exams. So let's start. What are the rules? The first rule is, we will draw a straight line of any length. Let us assume that we'll draw a straight line of 15 centimeters. Now as you can see, I've drawn a line, straight line of any length. I've taken it to be almost equal to 15 centimeter. It's your wish, you can draw a line of any length. The next step is mark any point on this line. Let's have this mark this point and named it as C. The next step is to take a compass and open it for a radius of any even number. I prefer 8. You can take it 10 or 6, but I prefer 8. Next step will be take the radius at 8 centimeter, put it on C and draw a arc. As you can see, I have drawn a arc. This arc will behave as a spherical mirror. If it is a concave mirror, I will shade it over this side, and if it is a convex mirror, I will shade it in the inner side. Now mark the point at which this curve cuts the line. It will be pole, and as you know, CP is the radius of curvature and the focus is at the midpoint. Since CP is equal to 8, so at 0.4 centimeter from either P or C, will mark F. You can see I have marked the point F. Now since the object is at infinity and we have to assume that the rays must be parallel, so we would be using the first law or the first rule, that is, if a ray is parallel to the principal axis, then it will pass through the focus. And for drawing ray diagram, we need at least 2 incident ray. Since in case of infinity, we can only use that the object or incident ray must be parallel to the principal axis, so we will be using only the first rule. As you can see, I have drawn 2 rays with red ink which is parallel to the principal axis. I will mark the arrows which will indicate that these are the incident ray. As per the rule, these rays must pass through focus. Now as you can see, these reflected rays are passing through focus and they are actually meeting at point F. So we'll say that the image will be formed at F. So the position of image will be at focus. Nature of image, as the reflected rays are actually meeting at a point, it will be real and inverted. And the size of the image will be highly diminished or point size. As you can see, only a small point is formed over here. So the size of image will be highly diminished or point size. You must remember this. Whenever you have been asked to draw a ray diagram, you have to write 3 points. The first is position of image, second is nature of image, and third is size of image. If you draw the ray diagram with proper measurements, you don't need to remember this. You can easily find these out from the ray diagram. As you can see, position, how to find out position? It is the point at which the reflected rays meet. In this case, it is as focus. Nature, if the rays are actually meeting, the nature will be real and inverted, as we have discussed in the earlier lecture. And size, as you can see, only a small point is formed over here, so the size will be highly diminished or point size. Moving on, we'll study the second case when the object is kept beyond C. In this case, you need to draw an object. These are the measurements. C, 8 centimeter, the arc at the midpoint F, and all those things. You need to draw it again. I've taken an arrow which behaves as an object which is kept beyond C. We'll assume that all the light rays start from the head. This upper portion is known as head. While drawing ray diagram, you can use any rule of your choice, any 2 rule of your choice. I have taken the first and second rule. The first rule is if a ray passes parallel to principal axis, it passes through focus. Second, if it is passing through focus, it becomes parallel. So as you can see, the 2 reflected rays are meeting at this point. At F, one incident ray and the reflected rays are meeting, so don't get confused. The image is only formed when the 2 reflected rays meet, and as you can see, the 2 reflected rays are meeting at this point. Since the light started from the head, at the point of contact the head should be made. If we draw the head, हमें कुछ इस तरह का मिलेगा. From here you can see that this is the image. From here you can see that the image is inverted and the rays are actually meeting. So the nature of image will be real and inverted. Nature of image real and inverted. What about its position? It is between C and F. C और F के बीच में कहीं भी हो सकता है. So it is between C and F. So the position is between C and F. Nature real and inverted. Size, as you can see, it is smaller as compared to the object. So the size will be small. Now moving on, we'll study case 3 when the object is at C. Here The arrow is behaving as an object, which we have already discussed, and it is kept at C. I have again used the first and second rule. If you again draw it with proper measurement, you will see that the image is formed just below C. So the position of image will be at C. The nature, as the reflected rays are actually meeting, it will be real and inverted, and size, you will see it is same as the size of the object. Next, and the object is kept between C and F. I have kept an object between C and F, as you can see in the diagram. Again, using the two rules, parallel passing through focus. Second, passing through focus becomes parallel. So as you can see, it is meeting at this point. So it is obviously beyond C. You can see the size of the image. It is highly enlarged or larger than the object, and nature is real and inverted as the rays are actually meeting. So position will be beyond C, nature real and inverted, size and large. You can clearly see in this diagram. So if you draw the ray diagram with proper measurement, you will get the answer, and you don't need to remember it always. You can write the answer just by looking at the ray diagram. The next case which we are going to discuss is when the object is at focus. So the object is kept at focus. The first ray, it is parallel passing through focus. Here I can't use the second rule as the object is on the focus. So what I have done is I have used the third rule. I'll draw a line such that it strikes the mirror and it passes through center of curvature. Then this will be the incident ray and it will get reflected back in the same direction. So this will be your reflected ray. As you can see, both the reflected rays are parallel to each other. It means the image will be formed at infinity. Since the image is formed at infinity, it will be highly enlarged. So whenever parallel rays come, you have to write infinity. So position at infinity, size highly enlarged, and nature will be real and inverted. So till now we have studied 5 cases. In all the 5 cases, the nature of image form was real and inverted. The 6th case is an exception one, and this will keep the object between principal focus and the pole. So as you can see, I have kept the object between principal focus and the pole. I am using the first rule, ray parallel passing through focus, and the third rule, ray passing through center of curvature. It retraces its path. As you can see the diagram clearly, the two reflected rays are diverging from each other. They are moving away from each other. If they are moving away from each other, it means they must have started from a point. Now how to find out that point? What we'll do is we will retrace back these lines in form dotted, and you can see that these two lines will appear to meet at a point. And whenever they appear to meet at a point, the image will be formed, as we have already discussed. Since they are not actually meeting, the image form will be virtual and erect. As you can see, an erect image is formed. So the nature of image will be virtual and erect, and it is enlarged as compared to the object. It is quite clear from the diagram. If you draw with proper measurement, you will get all this diagram clearly, and you can write the position of image will be behind the mirror. Nature, as you can see, the reflected rays are not actually meeting, so it will be virtual and erect. The size will be bigger than the size of the object. So position behind the mirror, nature virtual and erect, size bigger than the object. Now I'm explaining you a small trick which would be helpful for you in remembering the ray diagram. But mind this trick is only applicable for real and inverted images, that too for a concave mirror. So I have written all the position at which objects were kept, and I have connected the endpoints. At infinity is connected with at F. Beyond C is connected between C and F, and as C is alone, it will be connected with itself. As you can see, I have written the size in increasing order: point, small, same, enlarge, highly enlarge. Now how to remember this? See, if it is asked the object that is at infinity, where will be the image formed? Then it is connected at F, so the image will be formed at F, and the size will be point size. What if the object is kept beyond C? Image will be between C and F, size small. What if object is kept between C and F? If object is kept between C and F, beyond C, size enlarged. At C, the image will be at C, the size will be same. What if the object is kept at F? At F, it is connected to at infinity. It means when the object is at F, image will be formed at infinity, size will be highly enlarged. Object kept at beyond C, image will be between C and F, size small. So using this line you can remember the ray diagram. As we have already studied that there are two types of spherical mirror, concave and convex. We have studied how to find out position of image or image tracing on concave mirror. Now we'll study image tracing on convex mirror. For this we must again study rules for image tracing on convex mirror. The first rule is, if a ray is parallel to principal axis, then after reflection it appears to pass. It means it won't be actually passing. If I draw a convex mirror, this is a ray parallel and it will get reflected back. As we know, the focus is on the other side, so a reflected ray can't pass through it. But if we produce it, it will appear to pass through the focus. The reflected ray will appear to pass through focal. It won't be actually passing. Second rule, if a ray is passing through principal focus, if a ray is appearing to pass to principal focus, then after reflection it becomes parallel. As you can say, this is the incident ray. It can't actually pass through focus, but if I produce it, it appears to pass through focus, and after reflection it becomes parallel to the principal axis. The third rule, if a ray appears to pass through center of curvature, then after reflection it retraces its own path. If a ray is striking on the mirror such that if the mirror wasn't there, it would have passed through center of curvature. ये रे आ रही है, अगर यहाँ मिरर नहीं होता तो ये सेंटर ऑफ कर्वेचर से पास होती. So if such is the case, then the light will get reflected back along its own path. Using the three rules, we'll study image tracing on convex mirror. The first case which we are going to study is when the object is at infinity. As we have already discussed, in case of infinity we do not draw the object, and secondly we assume the incident ray to be parallel to the principal axis. So the two rays are parallel to the principal axis. Using first rule, we can see that they get reflected back in such a way that then they appear to pass through focus. They are not actually passing, they are appearing to pass through focus. So if the rays are appearing to pass through focus and they appear to meet at a point, the image nature must be virtual and erect, as the rays are not actually passing, they are meeting the reflected rays. The position at which they appear to meet is at focus. Size, as you can see, it is a point size. Second, when the object is kept at a finite distance. See, there are no points on the reflecting part of the mirror, so we can't mention any point. We'll write when the object is at finite distance. आप इस object को कहीं भी रख सकते हैं, पास में, दूर में, कहीं भी, but it should be at a finite distance. So as you can see, I've taken two rules. Rule 1, parallel appearing to pass through focus. Rule 3, if it appears to pass through center of curvature, it retraces. As you can see, the two reflected rays appear to meet at this point, so the image will be formed at this point. Since the rays are appearing to meet, the image nature will be virtual and erect. So nature will be virtual and erect. As you can see, the size is smaller than the size of object. The size is smaller than that object, and position of the image, it will be between P and F. So in this way you can trace various images due to an object on concave mirror and convex mirror. Thank you for listening patiently. Thank you.